This lab is about creating pieces of charged tape and discovering that amount of charge on the tape using both Coulomb's law and the momentum principle. When we create the tapes, we don't know the charge or the sign, but with the use of a negatively charged pen and the momentum principle, specifically when the net force on an object is zero, we were able to derive both the sign of the charge and the amount of charge. After this, we essentially make a computational model using GlowScript. Some of the observations we see is that the tape is attracted to random neutral items. We know that this is because the electric field produced by the tape creates induced dipoles in the neutral items, such as shown in the picture to the right, in a way that the two objects will then become attracted to each other. Another thing we have here is some pieces of data such as the length, mass, distance between the tapes, and the two forces acting on the tape itself. A key observation is that once the tape is brought close to a negatively charged pen, they are attracted, meaning that the tape is positively charged. But now, how do we find charge? To get the charge, we set up a scenario so that the tape levitates over the secondary tape. This means that the gravitational force is equal to the electric force since the two tapes are like charges. We can make this assumption since both of the tapes were created in the same manner, therefore they should have the same charge. Once we set the magnitude of the gravitational force and the magnitude of the electric force together and we do a little bit of algebra, we get the equation for Q shown in the second picture on the right, with 0.0049 being the gravitational force. Once we plug in some actual values, I got that the charge of one of the tapes is 2.2 e to the negative 8 coulombs when the separation is 3 centimeters. So now we want to figure out what fraction of atoms actually gave up electrons. And a way to do this is to first get how many atoms there is, which is done by getting the area of a tape divided by the area of an atom. We can get the area of an atom just by assuming that it's a square and that each side is 1 times 10 to the negative 10. Now we want to figure out how many charged particles there is, which we can get by taking the charge and dividing it by 1.6 times 10 to the negative 19th coulombs. And then finally we put the number of charged particles divided by the number of atoms to get the ratio, which I got to be 1.37 e to the negative 7th. For the coding portion, I basically just made a diagram in GlowScript of the forces acting on the two pieces of charged tape, and some of the assumptions we have here is that there's no air resistance, that the two tapes have the exact same charge, and that the tape can be treated as a point particle. When we actually run the code and get the different diagrams that I have created, we get exactly what we expect. In the first picture, we have just gravity pointing down for both items, and in the second picture, we have gravity and the electric fields, which we expect to be in opposite directions of each other, since the force that's going to be exerted on them should be opposite of each other since they are like charges. In the third picture, we have gravity and the electric force, which we assume for the top tape only that they are in opposite directions and the same magnitude, so that tape will not be moving and the net force would be zero. In the third picture, we have all of the arrows acting on the two balls, essentially gravity, the electric field, and the electric force. And I also have printed out the charge that we have, the magnitude of both of the forces acting on the tapes, which are equal but opposite. And I just want to make a little note that some of the arrows, specifically in the last picture, are inside of the other arrows. I'm sorry about that. Now, what would we observe if electrons had a positive charge and protons had a negative charge? Actually, we would notice no difference in the experiment, since the two things that would repel would still have like charges, and the two things that attracted would still have opposite charges. The only main difference would be that the dipoles created in the neutral objects would be in an opposite manner, so that if something positive was inducing the dipoles, it would not be something negative inducing the dipoles, causing the dipoles to be flipped. Another question is, why is it important to handle the charges tapes as little as possible? This is because our skin has ions on it that can take away some of the charge of the tape, which would essentially reduce the charge of the tape drastically if we kept touching it over and over again. In conclusion, we see that we can create charged objects through contact, but these charges are always conserved. If one thing is not positively charged, that means that something else has a negative charge. We also see that these newly charged objects create electric fields that can cause induced dipoles in neutral objects, creating an interaction that we would not normally expect. Also, we can take advantage of the momentum principle, specifically when the net force on an object is zero, to derive different things such as charge that we normally would not have before. We also see the advantage that a coding such as in GlowScript has in creating physical representations to calculate values to an extremely high accuracy.